This is the assignment 502.1 Momentum Intro problem set. I'm going to work through the problems starting with number 1. A Somali ostrich with a mass of 129 kilograms runs to the right with a velocity of 13.08 meters per second. Calculate the momentum of the Somali ostrich. So our equation here for momentum, P, equals mass times velocity. That is the formula that you learned for momentum as we started this unit. When you read the question, we have both a mass and a velocity given to us, the mass here being 129 kilograms, and we're multiplying that by the velocity, 13.08. And so that's what you're going to do in order to calculate the momentum of this ostrich, is simply multiply those two values. 129 times 13.08 gives me a momentum of 1,687.32. So let's go ahead and type that, 1,687.32. Our units for momentum are kilograms times meters per second. Again, because we multiplied kilograms times meters per second, that's the unit that we're going to use here for momentum. And it does have a direction. Momentum is a vector quantity. It will always be in the same direction as the velocity. And since the velocity is to the right, so is the momentum. Question number 2 says, the thoroughbred moose is among the fastest land animals in the world and is used in famous racing events such as the Kentucky Derby. There is an up-and-coming star in the world of thoroughbred moose racing named Charlie. His mass is 4.08 times 10 to the second kilograms. If Charlie gallops with a momentum of 5.57 times 10 to the third kilograms meters per second to the west, what is his velocity? And so whenever we take a look at this, it's very similar to the last question, except this time, same equation, but this time they gave us the momentum and they are asking us to solve for velocity. So when we substitute in for this problem, again, now we have the value for P. The momentum is 5.57 times 10 to the third equals, the mass is 4.08 times 10 to the second, and we're solving for velocity. You can take these and put these values into standard form instead of scientific notation if you would like to. That would be 5.57 times 10 to the third would be 5,570. 4.08 times 10 to the second is 408. Okay, and so that's really what you're doing here. In order to isolate this variable, we're going to divide both sides by 408. And again, if you left it in scientific notation, you will get the exact same answer. You do not have to convert this into standard form. But 5570 divided by 408 is 13.65. If I round it to 2 decimal places, that's what I get. So let's go ahead and type that in, 13.65. The unit for velocity here will be meters per second, and the direction is to the west because it will be in the same direction as the momentum. Question number 3 says, the largest species of hummingbird is the Patagonia gigas, or the giant hummingbird of the Andes. This bird has a length of 16 centimeters and can fly with the speed of up to 47.8 kilometers per hour. Suppose one of these hummingbirds flies at this top speed. If the magnitude of its momentum is 0.319 kilogram meters per second forward, what is the hummingbird's mass? And this is going to be very similar to the problem that we just did, where you have to do a little bit of algebra to rearrange it. But whenever you look at this one, we are provided with a momentum. So again, it's the same equation, P equals m times v. But this time our momentum is pretty small, 0.319. And we're going to set that equal to mass times velocity. The mass this time is what we're solving for, and so we just need to plug the velocity in right here. However, the velocity that we're given in this question is 47.8 kilometers per hour, and in order for us to actually use the velocity, it does need to be in units of meters per second. So before we can plug it in, we have to do a conversion. 47.8 kilometers per per hour, and we're going to convert this into meters per second. So we're going to have to do two different conversions here. One of them to convert kilometers into meters. There are 1,000 meters in a kilometer, and you're setting that up so that they cancel. And then the other one, because right now we have meters per hour, we need meters per second. The other one is for hours. So again, because we have hours on the bottom there, we'll put 1 hour up here, and 1 hour is equal to 60 minutes. And again, I don't want minutes, I want seconds. Cancel those hours though. One more step, 1 minute is 60 seconds. Now we've canceled the minutes, and the remaining units are going to be meters over seconds, which is what we want. So let's go ahead and put this into the calculator. 47.8 times 1,000 divided by 60 and divided by 60 again gives me 13.28. And again, this isn't my answer. This is simply the velocity that I need to use right here. 13.28 is my velocity in meters per second. So now that I have the correct units and I can plug them in, because again, look at this value in the question, kilogram meters per second. This is also meters per second. So whenever we actually go to solve, those meters per second will cancel, leaving us with just kilograms, which is what we want for our mass. To solve for this, we need to divide both sides by this value. So we're going to type 0.319 divided by our answer. And that's going to give us a rather small number, which is why the directions at the bottom tell us to include at least 3 decimal places, which is a different rule than normal when we're using MyOpenMath. Okay, so 0.024 is 3 decimal places. Question number 4 says a 2,750 kilogram pickup truck has a velocity of 23.76 meters per second to the east. With what velocity would a 1,070 kilogram car have to be traveling in order to have the same momentum? Okay, so if we want to figure out what it needs to have the same momentum, we need to know what the momentum of this truck is. Again, it's still the same equation. So we're still going to say that momentum is equal to mass times velocity. And for the pickup truck, that means that its momentum is going to be equal to 2750, its mass, times its velocity, 23.76. So let's go ahead and figure out what that is. 2750 times 23.76 gives me a momentum of 65,340. Kilogram meters per second. That's not our answer though. This question isn't asking us for that momentum. Rather, it's asking us, hey, here's this other vehicle, a 1,070 kilogram car. How fast does it have to be going in order to have this momentum? Okay, and so it's a second calculation. It's still P equals M times V, but this time we're going to start with the momentum we just found, 65,340, and we're going to set it equal to this car's mass, 1,070, and figure out how fast that car would need to be going in order to have the exact same momentum as the truck. So we're going to take this and divide both sides by 1,070 to isolate that variable. So answer divided by 1,070 gives me a velocity of 61.065. And you can type those digits out. You don't have to round to 2 places. If I did, I'd have to do 61.07. You do have to round correctly. And again, this one up here was going to the east, so this needs to also be going to the east. Question number 5 says, what would happen to an object's momentum if its velocity were quadrupled and its mass were tripled? The momentum will change by a factor of. You get to type the factor in, and you can type it as a whole number, a fraction, or a decimal. So looking at the relationship between these variables, and again, it's really the equation we want to look at here. Okay, looking at this equation, your momentum, if your mass is larger, your momentum will also be larger. So if this gets multiplied by a factor of 3, this would also be 3 times as much. However, It's not just changing mass here, it is also changing velocity. And it says the velocity is quadrupled. And so if you do both of these things, and it's not just 3 times, it's not just 4 times, it's 3 times 4 times, which means 12 times as much, because each of those factors has a directly proportional relationship with the momentum. Question number 6 says, which of the following objects most likely has the greatest amount of momentum? Again, same formula, P equals m times v. Our options here are the North American continental plate, which has a mass of approximately 5.38 times 10 to the 22nd kilograms, a speeding bullet with a mass of 0.3 kilograms, a stationary elephant, or a flying bee. Right off the bat, you can eliminate the elephant and the bee. Okay, bees don't fly very fast. They also have very small mass. Elephant's not moving at all. Both of those are going to have 0 momentum. And so it really is between the other two. But that bullet cannot go nearly as fast enough in order to overcome this massive value that you have here. This North American continental plate has a mass so large, okay, that there's no way you'd have a bullet traveling that fast. And the North American continental plate does move very slowly, but it does move. And it doesn't matter that it's very slow. This is so large that it's going to be the larger of the two values. Question number 7 says, as an object slides down an incline, which properties of the object will increase? If you have something going down an incline, down a ramp, you're going to have acceleration. Okay, so obviously you're going to have acceleration. That doesn't mean the acceleration increases. In fact, your acceleration is going to be caused by some component of the gravity, and that value is constant. Okay, so the acceleration is not going to increase. It's going to be a constant acceleration. But that constant acceleration means my speed is going to increase. Okay, and when my, sorry, I'm not trying to click that. When my speed increases, my momentum will also increase. So again, don't select the acceleration. Although it's present, it is a constant value. It's just the speed and the momentum that are going to increase. Question 8 says, which correctly describes the differences between inertia and momentum? Our options here say inertia is a measure of force acting through a certain distance, while momentum is a measure of impulse. That is just incorrect. The second option says inertia is a measure of mass, while momentum is a measure of mass in motion. Those are the definitions that you were given in class, so we're going to check that box. The third says there is no difference between the two. Nope, that is definitely not true. And the last one says inertia is a measure of mass in motion, while momentum is a measure of mass. That is backwards. So it's just one answer here, and it's based on the definitions you wrote down, hopefully wrote down in your notes. Question 9. 3 physics carts can only move along a straight, level path. The motion of each cart is plotted onto a position time graph below. The magnitude of the momentum of the physics cart increases in which of these cases? So again, if your momentum is increasing, your momentum would change if your velocity changes, because again, your equation for momentum is mass times velocity. So if your mass changed, which again isn't going to happen with a cart, your mass is going to be constant for that given cart. So it's really just the velocity. And if you have this cart and you want to know where your momentum is increasing, you just need to know where your velocity is increasing. So you need to find a cart that shows acceleration with an increasing velocity. On a position time graph, acceleration is a curve, and it needs to be a curve that gets steeper, because that means that you have an increase in your, again, you're looking for that increase in momentum. And so the only one you're looking for here, the only one that's a possible answer is 3. Again, as a reminder, this first one, Roman numeral 1, is an object moving at constant velocity, therefore it would have constant momentum, but it is moving. Object 2 is not moving, it's at rest. And object 3 is the only one that would have an increase in its momentum, because it's the only one that is experiencing acceleration. That is the last question for this assignment 502.1 Momentum Intro Problem Set.